So starting with the first cash flow of $440, every period the cash flow will grow by 10%. Also, since we're finding the present value, it will be discounted by 8%. So the easiest way to approach these problems is to convert these two rates into a single rate. So here, let's just take the first cash flow. We know the first cash flow, we are going to grow it by 10%, so we're going to multiply it by 1 plus the growth rate times 1.10, but we're also trying to find the present value of all of these cash flows. So we're going to eventually discount them back all the way to period 0. But again, just looking at this first cash flow, that just means discounting it back one period. So that means dividing it by 1 plus the discount rate, which is 1.08. So this first cash flow, it's going to get grown by 10%, so we're going to multiply it by 1.10. Simultaneously, we're going to discount it back by the 1.08. So we've just combined both of those effects into this ratio. Well, if you compute this ratio, if you compute the decimal 1.10 divided by 1.08, it's equal to the number 1.0185. So multiplying the cash flow by this number is the same thing as multiplying it by 10% and then dividing it by the 8%. So if we multiply the cash flow by the 1.0185, it simultaneously grows it and discounts it. This is the strategy we're going to use for finding the present value of this annuity. We can actually make our calculator work for this problem by tricking it into thinking it's finding the future value, by tricking it into thinking it's compounding these forward, when in reality it's growing them and discounting them back all at the same time. So mathematically, again, multiplying by the 1.0185 looks like we're compounding the cash flow forward at 1.85%. Well, why is that? Because remember, when we compound something forward, the basic time value of money equation says that the future value equals the present value times 1 plus the interest rate. So again, we have this factor, 1.0185. If we subtract 1, we get the interest rate, and it's 1.85%. So that's the interest rate we're going to use. So, and this is exactly what we're going to tell our calculator to do. Note that even though we're compounding forward, again, we're still finding the present value, since the discounting is built into this 1.85%. So there are a total of 51 payments. Since the first payment occurs today, in year 0, when we find the future value in our calculator, mathematically it will look like we're finding it in the same period as the last payment. So it looks like a regular annuity. Okay, so there's pretty much two kind of things that you have to work out whenever dealing with a problem like this one. First is you have to find the interest rate. That one wasn't too bad in this problem. We already found it. It was the 1.85%. The next is figuring out how you want to set up your calculator to use it. Either you want to use it as an annuity due, a regular annuity, or you want to use one of them, but you might not get the value in the right time period. So it's hard to think through the process. But the idea here is, because the first cash flow occurs in year 0, well, think about what our calculator is doing. It takes the first cash flow, grows it and discounts it. It takes a second cash flow, and it grows the original payment by 2 periods of 10% and discounts it back 2 periods at the 8%. And it keeps doing that for all 51 payments. And so it's going to find the future value. But do we want the future value to be found in the same period as the last cash flow? Or do we want it to be found in one period later than the last cash flow? Because remember, the regular annuity, when you find the future value, the regular annuity has the future value in the same period as the last cash flow, and the annuity due has the future value found in the period after the last cash flow. Well, because you have to kind of think of this in reverse, since we want the present value in year 0, and our cash flow, our first cash flow occurs in year 0, if we treat this as a regular annuity and we find the future value, we'll get that value calculated in the same period as the cash flow. So in this case, it'll be in year 0. And that's exactly what we want. We want the present value of this annuity of payments in year 0. So we're going to treat this like a regular annuity. So now we can enter it into our calculator, and it'll do the rest. So there's 51 total payments. We enter in N as 51. The interest rate we're using is 1.85%. The annuity payment is $440. And when we solve for future value, we get $36,810.60. And this is, again, the present value of the annuity. Because even though we solve for future value, the compounding and the discounting were built into this 1.85% interest rate.